Let's continue. Please forgive me. Accidentally, the first video ended on its own. I don't know what happened there. But anyway, to check if your system is, or if your solution set is correct, just substitute the ordered pair to every equation. Now let's consider a second example for systems of linear equations into unknowns. Let's say we have this as our system, 2x minus 3y equals minus 2 for equation 1. And then equation 2, let's say, is 4x plus y. 4x plus y equals 24 for equation 2. That's our system. And let's choose a variable to be eliminated. Compare now your coefficients. For x, you have 2 and 4. For y, you have 3 and 1. So you can eliminate any if you may choose. So let's say in this case, let's eliminate. So if you will eliminate x, you have to multiply equation 1 by 2. If you would like to eliminate y, you have to multiply equation 2 by 3. But I think it will be easier to eliminate x. Let's eliminate x. And in this case, we have to multiply equation 1 by 2. So we get 4x minus 6y equals minus 4. And equation 2 will simply be copied. We have 4x plus y equals 24. Okay, but since the signs of the terms involving x are the same, to eliminate x, we now subtract one equation from the other. Let's say we will subtract equation 2 from equation 1. In that case, when we subtract one equation from the other, we change the signs of the terms in the equation that we are subtracting, and then we proceed to addition. So this will now be 0. This gives us minus 7y equals minus 28. Then dividing both sides now by minus 7. This yields y is positive 4. And then, since we now have the value of y, positive 4, we substitute y, let's say, in equation 1. To solve for x, we get 2x minus 3 times 4, the value of y, equals minus 2. And that will now be 2x, that's minus 12. That becomes positive 12. Positive 12 minus, this is minus 12. Transpose it to the other side. That becomes positive 12 minus 2 is 10. Then divide both sides by 2. We get x is equal to 5. And that now should give us the solution set. Ordered pair x, y. X is 5 and y is 4. And that should now be our final answer. So how do we know if our solution set is correct? Go back to the system, substitute the ordered pair. It must satisfy both equations. 2 times 5 is 10. 3 times 4 is 12. That will be minus 12. 10 minus 12 is minus 2. 4 times 5 is 20. That's 4 times 5 is 20 plus 4 is 24. So we have the correct solution set. Now, what if we have three unknowns? Let's look at an example. If we have three unknowns, let's say x plus 2y plus z equals 8. And then let's say we have minus 2x minus 3y plus z equals minus 5. And then 2x plus 4y, or forgive me, that should be 2y. 4x, 2x 2x plus 2y, 2x plus 2y minus 3z equals minus 3. So that's our system. Let's call this as equation 1, equation 2, equation 3. Elimination. So if we will eliminate, what we want now is to choose one variable to be eliminated. So our system has three unknowns. We will eliminate one variable. Our goal is to reduce the system to two unknowns. So you can eliminate x, y, or z. Compare your coefficients 1, 2, 2, 2, 3, 2, 1, 1, 3. So I guess it will be easier to eliminate x. So if we will eliminate x, we can have first, let's say, equation 2 plus 3 because they have already minus 2 and 2 as coefficients for x. So that's minus 2x minus 3y plus z equals minus 5. And then we have 2x plus 2y minus 3z equals minus 3. So we can just add, that will cancel out. This is minus y minus 2z equals minus 8. Let's call this equation 4. Now, what will you do? You go back to the system, eliminate x one more time. Do not eliminate another variable. Because if you will eliminate another variable, you will get another equation, but involving different variables compared to equation 4. That's why we have to go back to the system, eliminate x one more time so that you get another equation involving y and z, so that you now reduce the system to two unknowns. So we have already utilized 2 and 3, so you can use 1 and 3 or 1 and 2. So let's say we use 1 and 2. We must first multiply equation 1 by 2. So that gives us 2x plus 4y plus 2z equals 16. And then equation 2, we have minus 2x minus 3y plus z equals minus 5. Opposite sign, so we just add. That will be 0. That will be y. This will be 3z. And then this is 11. Let's call this equation 5. Notice that after eliminating x twice, we now have reduced the system to two unknowns. Let's just rewrite it. We have minus y minus 2z equals minus 8, equation 4. And then equation 5, we have y plus 3y equals 11. Equals 11. That's equation 5. And this is now our new system. So obviously, we can eliminate y. And in eliminating y, we can just add. This will cancel out. This should be z, sorry. So that should be z equals, and if z is equal to 3, we can now back substitute to solve for y. You can substitute z in either 4 or 5. Sorry, this should be z. Therefore, substituting z in, let's say, equation 4, z in 4, what do we get? We have minus y minus 2 times 3 equals minus 8. We get minus y minus 6 equals minus 8. Minus y equals transpose, that will be minus 2. Divide both sides by minus 1. Y is positive. And finally, to solve for z, we can back substitute x, we can substitute y and z in, let's say, equation 1. So actually, you can substitute it in 2 or 3. So y and z in equation 1, we get x plus 2y plus z equals, that gives us x. This is 4 plus 3 is 7. Transpose 7. 8 minus 7 is 1. There you have it. Therefore, if you will now write your solution set will now be your ordered triple x, y, z. 1, your y is 2, your z is 3. So this is now our solution set. If you will check if your solution set is correct, your ordered triple should satisfy all the equations. So let's check. X is 1, y is 2, z is 3. So this is 1 plus 4 is 5 plus 3 is 8. 8 equals 8. Equation 2, that's minus 2. This is minus 6. Minus 2 minus 6 is minus 8. Plus 3 is minus 5. Okay. That's 2 plus 2. 2 plus 4 is 6. 6 minus 9 is minus 3. Minus 3 equals minus 3. So we have the correct solutions. So there you have it. An example of a system of equation in 3 unknowns. Before we end this example, or before we end this video, let me give an example wherein how do we determine if the system will have no solution or two solutions, or no solution or infinitely many solutions. Let me give this example. So let's say we have the first equation as x plus 2y minus z equals 4, and then we have 2x plus y plus z equals minus 2, and then we have x plus 2y plus z equals 2. So this is our system, equation 1, equation 2, equation 3. So if we will use elimination here, what do you think is the easiest variable to eliminate? Isn't it? It would be nice to eliminate. Let me just revise this. I think this should be, let's make this positive. So if we will now look at this, we can eliminate, let's say, what do you like? Let's eliminate z. So if we will eliminate z, let's say we can have equation 1 minus equation 3. Equation 1 minus equation 3. So we have x plus 2y plus z equals 4. And then we have x plus 2y plus z equals 2. Since we are eliminating z, then we have to subtract. Let's subtract equation 3 from 2 because they have same signs for z. So we change the signs of this equation, the signs of the terms of this equation, and then we proceed to addition. But notice x minus x will be 0, 2y minus 2y will be 0, z minus z will be 0, and then we have 4 minus 2 is 2. What happens? We have eliminated all the variables, and then we have an inconsistent equation here. 0 is not equal to 2. So if this is the case, if you obtain something like this, your conclusion is the system has no solution. In other words, if you will graph this, equation 1 and 3 will represent parallel lines. So that's an example wherein the system has no solution. And on the other hand, if we have this example, we have 3x minus y plus 4z equals 7. And then we have x plus y plus z equals 1. And then we have 6x minus 14 equals 2y minus 8z. So let's call this as equation 1, equation 2, equation 3. That's our system. So if you would now check this out, let me just rewrite equation 3. So if you will rewrite equation 3, that's 6x minus 2y plus 8z equals 14. That's equation 3. And then equation 1 will be 3x minus y plus 4z equals 7. And then we have x plus y plus z equals 1 for equation 2. Now, if we will eliminate a variable, let's say let's eliminate y. Okay, so let's eliminate y and let's use equation 1 and 3 just to drive the point here. So let's multiply equation 1 by 2 since we are eliminating y. That will become 6x minus 2y plus 8z equals 14. And then equation 3, we get 6x minus 2y plus 8z equals 14. So remember, we are eliminating y. So if we will eliminate y, let's subtract equation 3 from equation 2. We change the signs of all the terms in this equation, and then we proceed to addition. 6x minus 6x is 0, minus 2y plus 2y is 0, 8z minus 8z is 0, 14 minus 14 is 0. So what happened? We get 0 equals 0. So in the earlier example, we had 0 equals another constant, inconsistent. That's why the system had no solution. So if this is now the case, you get 0 equals 0. Your conclusion here is the system will has infinitely many solutions. The system will have infinitely many solutions. Why? If you will notice, we obtained here two equations that are exactly the same. Therefore, these two equations are representing two the same straight lines. Therefore, these lines are coinciding. We have infinitely many solutions. So at least that will be how you will be seeing whether your system will have a unique solution, an infinitely many solution, or your system has infinitely many solution or no solution. Okay, so I'll end this video so that it will not be that long. Your next video will be on solving systems of linear equations using another solution, that is by